I'm now going to work some examples for you of possible correct answers for the representing proportional relationships through a table mastery. And please remember that you need to be making corrections on your paper along with me if you want to get full credit for test corrections and get an opportunity to retake your mastery quiz. So you should be making corrections on your original quiz and filling out your test correction sheet paper at the same time. So the first example that we have is table number 1, and I'm going to show you a couple of different ways that you could have decided whether or not it was correct. First of all, remember that if something's proportional, if you take your y and divide it by your x values, that's going to give you a constant of proportionality. In other words, if you take your y by your x and divide and get the same answer all the way down, that means it's a proportional relationship. So I'm going to use that first, and I'm going to take all my y values. So remember, these are all my y values going down this column, and I'm going to divide them by the corresponding x values. So I'm going to do 11 divided by 6, 7 divided by 2, 20 divided by 15, and 17 divided by 12. And if I get the same number all the way across for all of these, then that means it's a proportional relationship. So if I do 11 divided by 6, I get 1 point. If I just round, I'll just leave it at 1.8. 7 divided by 2 is 3.5. Oh, I can just go ahead and stop right there because I can see that already by doing 2 of my y values divided by x, I do not have the same constant of proportionality. So I would say the answer is no. And down here I need to explain. So I've shown a lot of my work, and that is actually just fine with me if that's what you choose to do, show your work. So I would say no constant of proportionality. But I can't just say no constant proportionality. I need to have some kind of work to back it up, exactly like I do here for number 1. Another way that you could have explained your answer is by looking at how you scale from your x to your y. I'm going to make this a little bit bigger so that I can see. So from 6 to 11, actually, let me see here. So if I do from 2 to 7, no, let's do it this way. Okay, so from 6 to 2, I'm dividing by 3. 11 divided by 3. If 11 divided by 3 is 7, then I know that I can scale up and down by the same number. It's not, because it's I'll just round it to 3.7. So that is another reason, because I scaled from 6 to 2, I scaled down by 3, but from 11 to 7 is 3.7. It is not 3. So that would be another reason I could say, because you don't scale down by the same number. And a lot of you guys wrote that on your quiz, but you didn't actually show any kind of work here. And you need to show some kind of work. That I divided by 3 for both of them, but I didn't get the same number. For problem number 2, I am going to use the same 2 strategies that I did for problem number 1. First of all, I'm going to take my y values and I'm going to divide them by my x values and see whether or not I get a constant of proportionality. So I'm going to take, remember, this is your y and this is your x, because your y is always on the right. So I'm not going to do 10 divided by 4. I'm going to do 4 divided by 10, then 8 divided by 20, 12 divided by 30, and 16 divided by 40. If I get the same answer all the way across, that means that I have a constant of proportionality. So 4 divided by 10 is 0.4. 8 divided by 20 is also 0.4. So far this is looking good. 12 divided by 30 is also 0.4. And 16 divided by 40 is also 0.4. So I am going to say yes, because my constant of proportionality, I'm just going to write COP, is 0.4. And I've shown some kind of work to justify my answer. Another way you could have shown your work is by seeing that you can scale up and down by the same number. So from 10 to 4, obviously I'm scaling down, so I need to figure out what I'm dividing by. 10 divided by 4 means that I would be scaling down by 2.5. So if I can scale down all the way across by 2.5, I've got myself an answer. So let's see, 20 divided by 2.5, yep, is 8. 30 divided by 2.5 is 12. And 40 divided by 2.5 is 16. So that is another reason I could say yes, all x's scale down by 2.5. That would be another reason. So you've got two different choices for what you could pick for your correct answer. For number 3, I would say probably the easiest way is just to look straight across and see how I'm scaling up or down. Although, of course, I could still do constant of proportionality as well. So I'm looking from 2 to 10. I have to multiply 2 times 5 to get 10. Then it's proportional as long as 6 times 5 is 12. But 6 times 5 is not 12. That would be 30. So I've got some kind of correct work shown here, showing that if I scale up by 5, it doesn't come out right. So I'm going to say no, it's not proportional. I'm going to shorten because. And there's a number of ways I could phrase it. I've got my work shown right here over to the side, so it's good enough for me to say because don't scale up by same number. In order to go from 2 to 12, you would multiply by 2, not 5. And as long as you've got some kind of work shown here, I'm okay with an answer like don't scale up by the same number. But you've got to show me some kind of work to explain how you know that it's not scaling up by the same number. You could also still do the constant of proportionality. So if I do my y divided by my x, that would be 10 over 2. And 12 over 6, and actually those two are good enough because 10 divided by 2 is 5, but 12 divided by 6 is 2. So I could also say no because does not have a constant of proportionality. If I take my y values and divide by my x values, I do not get the same number. So that is another reason I know that it's not proportional. Last but not least, I think for this one, the easiest way to do it is just to see how I'm scaling down. From 6 to 2, I would have to divide by 3 in order to scale down. So this is a proportional table as long as I scale down by 3 all the way down. So let's see. 9 divided by 3 is in fact 3. 24 divided by 3 is 8. And 3 divided by 3 is 1. So I would say yes because all x's scale down by 3. Remember, it's not good enough to say they scale down by the same number without showing some kind of work. So when you make your quiz corrections, make sure you've included that. And more importantly, when you're taking your quiz retake, make sure you include that as well.